Good morning, guys. Today our topic is transmission parameter and our ABCD parameter. Okay, that is meter, or it is called ABCD parameter. So from this name, we can understand this parameter is widely used in transmission line, and not only the transmission line, this is also used in telephone line, also used in guided microwave line. Okay, and this is in the form of normal transmission theory and as well as cascade network. Okay, so we can just state that the transmission parameter are widely used in transmission line theory and as well as the cascade network. So for first, the write down these things. ABCD parameter are widely used in transmission line theory and cascade network. Okay, so first of all, we have to draw this block diagram. This is +1, that is -1, that is +2, -2, and this is a network, and that is I1 entering I2. Okay, this is V2. You all know that. Just recall that is V1. Okay, and that is the network. Okay, so it has some properties. The input variable, that I1 and V1, is the input variable of this port 1 and 1 test. Sorry, +1 and -1, that is called the sending end. That is called sending end. Okay, just remember this name, just recall this name, because in question you have to face these things. What is the receiving end? Then the port, this V2 means output port, +2 and -2, this is called receiving end. Okay, and this transmitter parameter, this is the transmission parameter, are also called the general circuit parameter. Okay, this is also called the general circuit parameter. So in some book you will get the transmission parameter, or sometimes you can get that is the general circuit parameter. Okay, or it is another also, it has another name that is called the chain parameter. Sorry, this is not G, this should be C. Chain parameter. Okay, so this is the few things, and you know we have to write it. If we going to write this parameter in the equation form, then V1 equal to A, that is V2 minus VI2, and that is not V2, that is the I1. Okay, so see V2 minus B I2. This is D. Sorry. A B C D. Not B. D I2. Okay. And this negative sign is coming for minus I, not for minus I2, not for this B and D. Okay. So you can write in this matrix form, you can write in the matrix form, that is V1, I1, and that is A, B, C, D. A, B, C, D. Okay, and this is V2 minus I2. This is the matrix form. Okay, and this one is called the transmission parameter or transmission matrix. Okay, so this is called transmission parameter, transmission parameter, or the transmission matrix. Okay, so now we have to find out the A, B, C, D. Okay, A, B, C, D, we have to find out. Look, when this port means output port or the receiving port or the +2 -2 port is open, when it is open, then we get the I2 is the 0. Then we have to find out this A1 and this C. Sorry, not A1, this is A and C. So the port 2 2 or the receiving end open. Okay, means I2 equal to 0. Okay, then we will get from this equation V1 equal to, that is V1 equal to A V2 minus B I2. This portion became 0 and only this. So we get A equal to V1 by V2, A1 by V2, when I2 equal to 0. Okay, so you can see this is the input and this is the output. But whenever we go for any gain analysis of gain, then we are giving the output by input. So we have to just flap it. So 1 by A equal to just V2 by I1, V2 by V1, and then I2 equal to 0. We have to write down. Okay, this term is called the gain. Okay, gain, and this is due to 2 1, and it has a particular name. You have to also write that I2 equal to 0. It has a particular term. This is called the open circuit voltage gain. This is called, just remember this thing, but because from this portion so many short questions are asking. Open circuit voltage gain. Okay, this G, or you may say this 1 by A. Okay, likewise, when I2 is 0, we also get another parameter, that is C. Okay, C is just like I1 by V2 when I2 equal to 0. Okay, but you can see that is input by output, but and it is not coming any option. So we have to change. If I change voltage by current, then we get some impedance. So if we change this 1 by C means voltage by current, when I2 equal to 0, we get that is Z impedance, that is 2 1. When I2 is 0, it has a particular name that is called the open circuit transfer impedance. Open circuit transfer impedance. Okay. So this 1 by C or Z21, it is called open circuit transfer impedance. So we have more another two things, then B and D. Okay. So now we have to make port 2 dash or the receiving end as a short circuit. Making port 2 dash or the receiving end short circuit. So V2 became 0. Okay. Then we get minus B equal to V1 by I2, where V2 equal to 0. And similarly, look, V by I. So if I just change this minus 1 by B, then we get I2 by V1 when V, because this is the input and this is the output, actually output portion. So that is called admittance. So that is 2 1, and that is called admittance, that is called short circuit transfer admittance. Okay. And similarly, we get D minus D equal to what? I2 by I1. Okay. Sorry. This is I1 by I2. This is as per the same. This is look. This is I1 by I2. Okay. Input by output. Okay. Then we have to change 1 by D. So that is output by input. When V2 equal to 0. When V2 equal to 0. So this is also called a specific name. This is alpha to 1 when V2 equal to 0. This is called short circuit current gain, but it has no dimension. Look, this is ampere, so it has no dimension. So it is called also dimensionless short circuit current gain or simply short circuit current gain. Okay. Short circuit current gain, this is dimensionless. Okay, so this is all about ABCD parameter. And another thing is that there must be a cascade connection. Okay, because in the telephone system, microwave network, radar system, they are using the cascade network. So what is cascade network? Look, that is cascade network means one after then. So that is cascade connection. That is V1, that is I1. Look, this is the X network and this is the Y network. Okay, so we can express that is AX, that is BX, that is CX, this is X, this is X, this is X, and DX, and that is AY, that is BY, that is CY, that is DY. Okay, so it is V2X, that is V1Y, that is V2Y. Okay, so V1, V2, V2X. Okay, so a current is flowing, that is I to X. This is the 2 terminal, and that is I to Y. Okay, so in this way we can draw the matrix, that is V1 I1 equal to AX CX CX, that is BX, and DX equal to V2X minus I2X. Okay, and for the Y matrix, Y network, it would be V1Y I1Y equal to, we can say that is AY BY CY DY, and that is V2Y I2Y. Okay, okay, so for the port 2 test, V2X equal to V1Y. Okay, V2X equal to V2Y. Okay, and I2X equal to minus of I1Y. Okay, so if we the result, combining these two matrix, we can get the resultant matrix is V1 I1 and AX CX BX DX AY BY CY DY, and that is V2 minus I2. So ultimately we get that is V1 I1 equal to A B C D and V2 minus I2. Okay, this is applicable, just write down the application. This is applicable in the telephone system, microwave, guide guided network, radars, etc. Okay, Okay, so this is our ABCD parameter. Now we have to perform a numerical, otherwise these things will be not clear. So find transmission or general circuit parameter meters for the okay. So find out the A, B, C, D. Guys, just try to do yourself. I am taking the attendance. Guys, just solve this math numerical. Otherwise, I'm doing this. First of all, we have to find out we we have to write down the general equation. Okay, So A, that is V2, B I2, I1, that is C V2 minus D I2. Okay. Now, when circuit this portion is open, so when port B minus B or B test, okay, is open, then I2 is 0. So circuit will be just like this. Okay, that is V1, that is 1 ohm, that is 5 ohm. It has no meaning. Okay, you can measure V2 from here. Okay, so we know that is A equal to V1 by V2. Okay, when I2 equal to 0. So from this equation we can find out that V1 equal to 1 plus 5, 1 plus 5 into this current, it is I1. Okay, okay, and V2 is just V2 is current is flowing, V2 is 5 into, sorry, that is I1. Okay, so put this value, that is 6 I1 and that is 5 I1. So just cutting down and we are getting A equal to 6 by 5. Okay, similarly, okay, similarly, this is also again, if you change this 1 by A, sorry, here you can change, if you change 1 by A, then we get 6 by 5. What is the name of this things? That is called G21, and it has the name of, what is the name? Open circuit, because circuit is open circuit, voltage by voltage, that is the voltage gain. So open circuit voltage gain, this is L, voltage gain. Okay, now we have to find this C. We know C is I1 by V2 when I2 is 0. So from this equation we can get, just put this value, V2 is the 5 I1, so I1 it was cut down, it is 1 by 5. So if we find out 1 by C, then it will be 5. And what is the name of these things? That is the impedance. Okay, this is 2 1. Okay, or if it is there, then it is mho, and this is impedance, that is ohm, you can say, or the resistance. It has the particular name. What is the particular name? That is open circuit transfer impedance. Open circuit transfer impedance. Okay, then we have to find out the B and D. Now we have to find out the B and D. When find out the B and D, then we have to short the sport. When B and B dashed is short circuited, then V2 equal to 0. So the circuit will be just like this. And make this path short. So this is the 1 ohm, this is the 5 ohm, this is the 2 ohm, and this is B and B dashed. This is A dashed. Okay, here is the V1, here is the V1, and you know that is V2 is 0. Current I2, that is current I1. Okay, so in this case, you can find out In this case, you can find out I1. We can say, look, this is this is 2 and 5. 2 and 5 means this is the parallel. So 1 plus 2 parallel 5. Actually, it will give you. Actually, it will be 1 plus 10 by 7. That is 17 by 7. Okay. So I2 is V1 by 17 by 7. We can say that is 7 by 17 into V1, that is I1. Okay. Similarly, minus I2 equal to 5 by 17 V1. Okay. And so if we put this B equal to minus V1 by I2 when V2 is equal to 0. So B equal to minus of V1 by minus of 17 V1. So ultimately cut down, we are get 17 by 5, that is ohm. If you write down this, and if this is 1 by B, then it is 5 by 17, and it is the admittance. Okay, so 2 1, it is called short circuit transfer admittance. Short circuit transfer admittance. Okay, so next item is our C. Next item is our C. Similarly, I1 equal to 7 by 17 V1, which we get, and minus I2 is 5 by 17 V1. Okay, so D, actually we are going to find out the D. D is, what is the D? Just remember, what is the D? D is,
I1 by I.
yes. What is this? What is
I1
this?
by I2.
I1 by I.
Yes, thank you. I1 by I2. And what is the name of these things? If I make
Short
1 by D, then what will be the name?
Short
short
circuit current and dimensional.
Yes. Thank you. Absolutely right. You all are great. Okay. Just remember that is I1 by I2. And if we go for the value, then 7 by 17, and it was coming minus. Okay. V1, and it was also given minus. So minus, that is 5 by 17 V1. So it will be cut down. 17 cut down. Already we get this. And if we get this 1 by D, then it will giving you the 5 by 7. And it is given by alpha 2 1. And it has the name. Once again, please tell me, short circuit.
Short circuit current gain.
Yes, thank you. Short circuit, because current I1 by I2, and it was given I2 by I1, means output by input. This is called gain, and this is for only current. That's why we are leaving current, that is gain. Gain. Okay, it is ABCD parameter is over for today, and if you have any question, then ask me.
sir. Sir,
Yes.
how did we calculate the minus I2?
Minus I2, because look, I2 direction is here. Okay, but whenever actually we are giving the voltage source over here, there is no voltage source. So current is flowing in this direction. Okay, so already we have to mention that is minus. And whenever we are going to calculate, then already this it is given taken as the minus I2. So
No,
in
sir.
yes,
Sir,
yes.
sir, my question is, how did we get 5 by 17 V1 minus I2 equal to 5 by 17?
Oh, minus 17. It was giving
Sir,
minus I2
on the
is
upper
by
side.
upper side. Here.
Yes, sir. Yes, sir.
Here I2 is minus already taken because the deduction.
Sir, 5 by 17 V1.
Oh,
वो
only this.
कैसे आया, sir? Yes, sir.
Yes. ये 5 by 17 कैसे आया है? Look. It is given that I1 equal to, here is the calculation. I1 equal to V1 by 17 by 17. In this way we are going on. Okay. So the current actually here it was divided. It was divided. So this current, whatever it is flowing, you have to find out. Okay. So here is no I2 is there. Then this current, if you give minus sign, then this current is say this is current is flowing Ix and Iy. Okay, because this current is divided here. This Iy actually I2. So we are giving this. You can't directly calculate this I2, but whenever in this circuit, simple this circuit, just current division rule. Just remember this current division rule. Main current, main total current, this is I1. This is total current into opposite resistance. Opposite resistance means if we divided these things, okay. So this is the 2 ohm, this is the 2 ohm, and this is the 5 ohm. Okay, so main current is I1. You can say that is the total current. So one is divided Ix and one is divided Iy. We have to find out this Ix. So as per this current division rules, hello, look. As per this current division rules, this I means I2 or the you can say Ix equal to the total current into opposite direction. You are finding 2. So opposite resistance, that is 5 by the total resistance, 2 plus 5, that is 2 plus 5, that is given. So I total is here, that is I1, and 5 by 7. So this is my current as per current division rule, that is Ix. So Ix means actually opposite direction of I2. So we are giving I2. Is that clear? Sorry, this is not 17. This is 7. This is 7. Oh no. It will be 7. Yes, this is 7.
Yes, sir. It is correct, sir. After putting the value of I1.
Yes.
Sir.
Is that clear?
Yes, sir. Yes, sir. Clear.
Okay. Thank you. Oh, okay, guys. Maybe 1 and 70. I forget that. It will be 17 or 7. What I can't remember. Just calculate it. Okay. It was 17. I just forget. No problem. Just process is just make this current division rule. And actually, this is the another thing. This is not related to this green side. Okay. So guys, have you any question? Okay, time is just 1 minute. Okay, I am going to stop here. Thank you. Have a nice day.
Thank you, sir.
Thank you.